Here's the next assignment. A lot of the focus of this assignment will be on implementing user interface testing. Right? We covered a little bit before this break, and then we covered it again last time we met, and we saw that there were certain principles for unit testing anything, right? That apply across the board, regardless of whether this is a front end or back end, middle tier. It doesn't matter. Some principles are the same, where we want to make sure that we isolate whatever component that we are testing, that we remove any dependencies with resources such as data resources or network resources, as well as we make them functional so that their state only depends on what we feed it, right? So that we can control its environment completely, so that we can set it up in a known state, then simulate several stimuli and see if the component behaves as expected. So this one, you should be already be implementing these principles when you are creating your unit tests already in Java, right? Which indeed they are, right? They're mostly just functions. They're algorithms that you give it the same input, it should come out with the same output, right? So they're already functional, right? So those were designed already with testing in mind. Here in the user interface, oftentimes is a little bit more challenging, since state management is often can exist in several places, right? It can exist on the front end, it can exist on the back end. So we need to be able to control where indeed it exists. This assignment focuses on a couple of things. It asks you to revisit some of the components that you implemented in previous assignments that you might have. For those that were using Redux or were using some of the more advanced state management techniques, this will not be an issue for those folks. They already might be a little bit ahead of the curve. For those of us who did not use Redux, we might need to refactor our components a bit. Right? We'll need to refactor them so that they're stateless, that they might have a container, and so that we can isolate it from the dependencies of dealing with its own state. Also, we'll need to isolate it from services, so that we can mock the data and the services, right? So that they can be injected, and we control the behavior of these services. You'll be asked to focus on a couple of tasks that deal with unit testing the front end. Right? In this particular case, we're using the library Jest. If you're familiar with other libraries, if you're from co-ops or whatnot, if you prefer to use Karma or Jasmine or whatever other library you might feel more comfortable, feel free to use whatever other library you prefer. But here we're asking you to use Jest, but feel free to use the same thing in the back end, right? If you're familiar with other libraries for testing, feel free to use those. Also, you were asked in the previous assignment to create some user acceptance testing criteria, right? So for some of the screens and components that you might have implemented, and here we're asking you to meet with other teams and ask and decide who's going to test what. So the idea will be that if you're Team A, then perhaps Team B is going to test some of the components that were implemented by Team A, and same thing. Team C is going to be testing some of the components implemented by Team B, and Team A will test some of the components from Team C. So it's kind of like everybody's testing each other. Okay, the testing is going to try to identify any deficiencies that exist between the expected behavior, right? That was captured in the specification from the assignment, right? And the actual behavior, and so you're asked to identify, quite a few defects that you might come across. Now, the defects don't necessarily only need to be those defects from when something is working not as advertised from the specification. You should also find deficiencies that perhaps you don't agree with the specification, or you don't agree with the original requirements, or you might identify that now that you're using it, now that you have a chance to play around with the user interface, you realize that it would have been better if you would have implemented some other way, right? Or that, maybe there was a missed requirement. You say, oh, it's behaving like the specification says, but actually the specification doesn't capture this, that, and the other. You might say it's missing. There might be some missing requirements. So you should always find yourself, challenging the requirements. Right? Why did we do it this way? Right? Why it would have been better this, and the other. So also you might find that there might be some other things that should have been implemented, nice to have things, right? That perhaps there might have been some discussions, and folks might say, yeah, that's nice, but we don't have time to do that. Well, those should be captured anyway, right? Those should be at least left in the backlog, so that things don't fall through the cracks, right? So things should be at least in some to-do list, and then certainly when the product owner or the business analyst, well, as they groom the backlog, right, they might decide, right? They might add priorities. They might say, well, this is a very low priority, this is a high priority, and they might be able to sneak in some of these requirements, some of these low-level hanging fruit things, and include them in some future sprints. But nevertheless, it's a good idea to capture them, not necessarily as a defect, but maybe as a nice to have. So this acceptance testing asks you, right, to be fairly fairly rigorous, not only to verify that it's behaving as advertised and the specification according to what the assignments might have asked, but also go beyond what the specification asks you, right? Be critical about the specification, right? About the requirements. You should always assume that you shouldn't always blindly accept what you're being asked to do. Okay, always challenge the system. Also, you'll be asked to start setting up Jenkins. Right, so this might take more than just one sprint. This one just asks you to set up an account. The TAs are gonna grab, gonna take the users that from the same organization, and they're gonna create a Jenkins folder for you, so that you can work under that folder. The name of the folder will be the same name as your organization, and you'll only have credentials to go into that particular folder. Yes? No, if you have all that set up, then just inform the TA, create a story, and say, well, here's the continuous integration. Maybe you want to ask them to create an account for them so that they can come in and take a look. All right, so let's take a look at this. Oh, so again, this first part of Jenkins is going to be trying to set it up, connecting it to your pipelines, your Jenkins pipelines, to your GitHub repository, automating some of the builds, and this first week might be a little painful as we set up everybody's permissions, and we'll get a lot of back and forth and saying, oh, it's not kind of working for me exactly. So this is this week, right? A little bit what was a little painful when we were setting up Jira. So I would expect that there will be something similar this week. So perhaps a lot of the things that we're being asked to do in this particular sprint might spill over to next sprint, and that's fine, right? So I would expect that hopefully by the end of next sprint, we should have Jenkins all set up and running smoothly. Okay. Let's see. Right. So I've broken up the different tasks here. The first one here is UI testing. This one is asking you to refactor any components that you might have implemented in a previous assignment, at least one component. So if last week you were working on, in services details or questions summary list, then stick to that. Stick to the one you might feel more comfortable. Perhaps you worked on 2 or 3 from the last couple of sprints. Just grab the one you feel more comfortable, that is more ready to go, and to refactor it so that it's you can isolate it from any dependencies that it might have. Dependencies with a network, dependencies with services, so that it's functional and it doesn't require to maintain its own state and any of its own handlers. I know quite a few of you are using Redux. If you're using Redux, then you probably already have this. Just inform the TA that you have already done this, and create the stories enough for the TAs to come in and take a look at what you've done. So you might already have a leg up on this, right? So you don't, you might not have to even do anything. Right. So grab the component you feel you feel more comfortable with, right, and refactor it. So also create some mock data that you can test your component with. If you already have some data that is stored in the database, that you're hitting it with a service, perhaps you can just hit that service and export it to a file. If you have already a JSON file with an array of lots of data, just save that to a JSON file that you can use as mock data. Yes.
Sorry to make you go back to you mentioned temporary things as stateless. Do you want us to just remove their state, or do you want us to fully rewrite the stateless function?
What do you mean?
As in, do you want us to use the React stateless function component setup, or do you just want to have them not?
So they could be written as classes. Is that what you mean?
Yeah.
But just not maintaining state. You can still use properties and whatnot.
Yeah. Do you want us to write them as?
No, they don't have to be stateless components, as long as they don't maintain their own state. As long as there's no this.state. Okay. So it only depends on the properties. Yeah. The functional is just a style that is, looks prettier.
I want to use it.
I'm sorry.
I want to do that.
Yeah. Yeah. You could. And also gives you a chance to play around more with ES6 syntax and whatnot. So you already have, you should already have services that are hosting all this data for you, that provide the array of JSON data that you can download. You'll save that to a file, right? And that could be your mock data. Okay. I'm just suggesting here that you name your mock data using the name of the table from where you retrieve this data. So, for instance, if it's a service, then it'd be service.mock.json. If it's a question, then it's a question.mock.json. If it's a frequently asked question, FAQ.mock.json. Yes. So create a PR that keeps track of all these files that you're creating. Right. That all these should go in there. If the mock data is being shared among several students, so between several developers, come to an agreement with that other developer. Right? You might be sharing the same service if you're working on the details component and somebody else is working on the summary component. Make sure that the mock data might work for both of you, okay? And collaborate to create this mock data. Make sense? Same thing for the service, right? Here you're being asked to create a mocked service, right? That can be used to isolate the component from its dependencies with network dependencies or access to a database or anything like that. So you could, again, the idea here is that whatever it is that you're testing should not be dependent on anything out there. That you can isolate it and test its behavior and simulate everything around it, right, without the need of going out to a network and retrieving any of this. Again, it might be that 2 or 3 developers might be using the same service, right? So feel free to break it up amongst 2 or 3 of you, and perhaps one of you works on the update, one of you works on the create, some of you might work on some of the finder methods. So just div it up amongst yourselves, and so this will also give you a chance to practice, not stepping on each other's toes when you're sharing on the same file, right? Right. So on the testing side, we're asking you to do two types of testing. One is the snapshot testing that we talked about. I think it was before we went out on the break. Being able to compare the data, the calculated output of these tests of these components. These components, again, they depend on being executed or interpreted by an infrastructure. And the infrastructure in our particular case is the browser. The browser is the infrastructure that consumes the data generated by these components, and then it renders them for human consumption. Yes, but whatever the infrastructure is, in this, in our particular case, it's the browser. Again, we need to isolate it. We need to be able to simulate that infrastructure. In our case, it's by being able to render the DOM programmatically and without needing an actual browser, right? So we're asking you to implement two types of tests. One is a DOM testing. The DOM testing is it asks you to generate the DOM, make sure that if your state there were two items in some collection, that it checks to see if indeed there are 2 or 3 items that you were expecting in the DOM, right? That if you generated an event to add or remove something from the data model, that indeed the DOM was modified so that it no longer has that row or has an additional row as expected. So that's the DOM, and for snapshot testing, the same thing, right? It'll generate first an initial snapshot, and then 2 or 3 different versions of the same snapshot, but with the added data or removed data. So it asks you to implement some of that to check in also the generated snapshots. So the snapshots will become part of the source code, right? That will be checked into the source code as a mechanism to verify that your components are working. As you progress in the next couple of weeks, any new changes to the DOM that are valid, you might need to come back and update these snapshots, right? If there are legitimate changes, so that you can verify that the changes were intended or unintended. We're also asking you to up the code coverage, right? A couple of weeks ago, the target was to hit an 85% code coverage. We're asking you to up that to, I'm sorry, what was it? 80% a couple of weeks ago. We're asking you to up it to an 85. If you already hit 85, there's nothing for you to do in upping it. Just to create a story and say it's done. Make sure that the TA knows about it. That you've already covered. You already have an 85% coverage. The intent is to by the end of the semesters to have hit at least 95% coverage for back end coverage. We'll talk about coverage, the front end coverage, a little later. For now, we're just focusing on code coverage for the back end. Okay. All right. So user acceptance testing, or oftentimes referred to as UAT. This is testing that typically might be done by clients or by a representative of that client or somebody who's a proxy of that client. It might be also somebody part of your organization. It might be a business analyst or it might be a product owner that they are the representatives of the end user, right? And they might at the end of a sprint or every other sprint do a user acceptance testing, typically on code that has been deployed to perhaps to a QA machine, quality assurance machine, that that presumably as developers we have enough confidence to say that this is ready to be tested. I'm confident that there's no bugs, that this is ready for prime time, and so this is a first line of defense for the clients to identify if there are any issues, any unintended behavior. So since we don't actually have any clients, we'll have other teams be clients, right? To be representatives of the client, right? So perhaps a couple of weeks ago, you were asked to create a user acceptance testing for components that you would have written, right? Any screens, any detail screen or summary screens that you might have worked on to create a user acceptance test. Okay, we're asking you to meet as an organization. So meet as an organization and decide, who's going to test what. Make a list of all the things that each team has worked on, and agree amongst yourself, right? Which team is going to test which other team, right? Or I guess you might decide that that any member from one team can test anybody else, any other member from any other team, perhaps, but not from the same team. Okay. I haven't thought about that. If that's gonna create chaos. Anyway, so you'll test somebody else's implementation. Okay. But ideally from some other team, because their implementation of the back end, of the middle tier, and the front end might be somewhat different from what your particular team might have. Especially if the teams are not quite the same in level of skills. Okay, we'll start seeing that, right? We'll start identifying these kinds of issues where some teams will get lots and lots of defects, and perhaps others not. So each team should take on at least 3 components, meaning one, each developer, each team member should be testing at least one single component that belongs to someone else. All right, and go through the user acceptance tests. The user acceptance test should include login as Alice, with this username and password. Navigates to this link. Type the following in the input field. Click on this button. Expected behavior. A new row appears at the bottom. Okay, so that's one of the tests. And the other test will says select the item. Now edit it. Now click this button and whatnot. So everything should be displayed there, whatever the behaviors are. And so you as a UAT tester, you should go through all that and try to identify any misbehavior. And as you identify these defects, you'll need to log bugs against the original author. Okay, and you'll assign it to that author. But you'll need to explain exactly what steps you use to generate the bug. Right? Whatever defect that you log, you need to be very explicit. What is it that you did, and what is it that was expected, and what the actual value was. Okay. All right. Right. So those are the specifications. Right. You also need to compare this not necessarily against that UAT. You need to compare it also what the original specification said. You might also question whether the UAT test that the author wrote there is actually not in accordance with the original specification. It says, hey, that UAT test is wrong. You might have misinterpreted the requirements. That also is a defect. It says, yes, it's working the way you described it there, but it doesn't meet the requirement. Is this intended? Right. So that's an opportunity to question the requirements, question the implementation, and that everybody owns this. Right. And there's feedback going around that there's a consensus that yes, this is the way it's supposed to be done. Then we should update the requirements because the requirements do not reflect what's actually implemented. Make sense? Also, go further, go beyond the requirements. If maybe the styling is not consistent. Everything's nice and using nice rounded corners and whatnot, and everything has this nice highlight. But the input fields are all square and have no styling. Why not? Why isn't there consistency in the styling? Or you type something and when you click on create, you would have expected the fields to be cleared out, but they're not. Right? So that's another defect. Right? Perhaps it's not maybe it wasn't captured in the original requirements. Right? So you might have said that that's a missing requirement. Or that's a missed requirement. Okay. Also, some of the behaviors. There might be certain things that we might identify as a defect, but but it's actually in the process of being implemented. But you don't know that, right? And as a QA or engineer, if somebody gives you something, you're testing against the known requirements. So even if your buddy who you're testing tells you, we never implemented pagination, or we never implemented filtering, or we never implemented whatever, and that's upcoming. Well, you as a QA engineer, you're not going to know these things, right? So there might be, as far as you're concerned, a defect, right? That it's a missing implementation, but it's actually part of the has already been it might be part of in the backlog to be implemented yet, has not made it into any sprint yet. All right, but that's not your concern. That's the concern of the project manager and the business analyst later, to comb through those defects, yes, and say, oh, they identified a defect, and you'll realize, oh, but that's an upcoming requirement that we're going to work on, in phase 2 or whatever, yes. But as far as you're concerned, right, as a test engineer, you're not aware of any of this, right? Typically, test engineers and QA engineers are even part of a completely different team, right? That they often you don't have a one-on-one rapport. We're also asking you to do a quality assurance, code quality assurance, right? So take a look at not only the functional implementation. Take a look at the entire stack of the component, going down to the service, going down to the middle tier, going down to the repository. See if you can find any technical debt, right? That you don't agree with. Perhaps naming conventions, perhaps some shortcuts. And maybe the RESTful service is not actually RESTful. Maybe they're using a put when they should be getting a get, or vice versa. So anything that you see that is not right, okay, that you don't consider to be best practice, and log those as well, because that's technical debt that it might be working correctly right now, but the actual implementation is not correct. And at some point, that technical debt, we're going to have to pay it down, right? That's going to be accumulative over time, and at some point it's going to bite us in the future. So we're asking you to take a look at the entire stack, starting from that component down to the RESTful services, and back all the way to a database. All right, and then as you find this technical debt, log those bugs against the. Probably you won't know who to assign it to, right? So assign it at least to the author of the front end, so that it can be addressed by them. They will know who to address it in a upcoming sprint. Continuous integration, as I mentioned earlier, we're asking you to navigate to this URL. Let's see if I copy that. If you go there, you'll be asked to log in or create a brand new account. Right? We're asking you to please use the same CCIS username that you use to create the Jira accounts. Okay, this is not connected to LDAP. It's not connected to the CCIS security, right? So it's not going to validate whether that's an actual CCIS account. So we're just asking your cooperation to follow that convention, so that we know that it's the same user in Jira, it's the same user in Jenkins. Okay, all right. Don't make up names and whatnot. So we're asking you to create a story and assign it to the TA, and in that story, please ask your TA to create a folder for you, and that the name of the folder should be the name of your organization. Okay. Provide also a list of all the usernames of all the folks that are in your organization, the usernames that you use to create the account in Jenkins. Right? Once you create the account, copy the username, send it, put it as part of the ticket, and assign it to a TA. The TA will create a folder for you, and you'll do all the work in that folder. So they'll have to set up the permissions for you. You'll also be asked to create a Jenkins pipeline. We'll see how we do that today. That is connected to your GitHub, right? You'll need to configure GitHub. You'll need to create some credentials on GitHub and copy those credentials and log in and create a pipeline in Jenkins with those credentials, so that Jenkins and GitHub can talk to one another, right? And we're asking you to configure the pipeline so that it can detect when new check-ins are made into onto the master branch, and that it should kick off automatically the build in Jenkins, right? Jenkins will check out the master branch. We'll do a Maven clean install, right? And it'll just report. It'll just report if something went wrong. It will ask you to create a badge so that you can include that badge on a README file on in the repository, so that we can see whether the latest build was successful or not. Okay. Let's see. Next week, so we'll try to complete this week. If we don't completely complete it by this week, we'll continue next week. But the idea that what we want to do is to have the builds identified. That if something went wrong, if any tests failed, right, to stop the build, right, to not continue, right, and not push it to Heroku, right. If something went wrong, we want to make sure that we leave Heroku, never always stable, right. That we don't want to dirty the Heroku. Now, if this were a more complex environment, we might have multiple machines, right. We might have the development machine. We might have a QA machine, right, where we do testing. And then, whenever the tests are good and in QA, we might promote that to maybe even a staging machine, and then even to a production environment. Okay. Right now, it's a very simple, very shallow setup that we have. Right. We have just your development machine, Jenkins, and production. Right. So we want to, and Heroku. We want to at least protect Heroku. Right. That if the builds fail, we want to stop the build and not promote this to Heroku. Right. We'll do that next week. This week, we just want to do a read-only and see if we can identify some of the statistics in Jenkins. The next couple of things is that obviously every single sprint we ask you to have a sprint planning. We ask you to do the Scrum meetings, right, and to make sure everybody has enough to work with for the following sprint. Okay. And at the bottom, we just have deliverables for each one of these things. All right. Any questions?